Okay, here we are for 7. We're going to solve some rational equations. The numerators for these equations are unknown. Determine a value of x that cannot be a solution. Okay, so I'm not sure what the numerators have to do with this situation, because one thing that x reliably cannot be is whatever makes the denominator 0. So let's see, 3x minus 4 is the denominator. And I want to know what makes it equal 0 so that I can find a value of x that the solution can't be. So I'll add 4 to both sides. 3x equals 4. And then I divide both sides by 3. And x equals 4 over 3. Okay? Over here, what's something x cannot be? I can give you 3 of them. X cannot be 2. X cannot be 0. Let's put little lines through it, because it cannot be these things. Also, x cannot be negative 3. So, those work. Those are values of x that cannot be the solution. Number 3, let's fill in the blanks to write an equivalent equation. 18 over 11x. Okay. You could write, a student was like, can I write 18 over 11x? Yeah, technically you could. You can also put anything else you want. Like multiply top and bottom by anything you want, like 2. So you could make it 36 over 22x. Easy peasy. Oh, now they want me to solve it. Okay, interesting. I mean, they're trying to make me see something interesting. So this side equals this side. Let's solve it and see what happens. This is 36 over 22. The methods we learned to solve, we would get the common denominator and then get rid of the denominator. I'm just trying to think a way that this is going to go that's like not weird, but like cross multiplying would be a not weird one, but I also don't want to deviate from the way I taught it in class. And in class, I didn't really do cross multiplication. So let's do what we did in class. In class, we would have said we have to get a common denominator. So on the second fraction, we multiply top and bottom by 2. And then I get 36 over 22x equals 36 over 22x, which is obvious because that's what's equivalent. And now that I have the same denominator, I can forget my denominators, and this tells me 36 equals 36. And this was what was making me hesitate on doing it this way, because now it's like, what? Because x isn't here. You guys, this is a true statement. Whenever in algebra, anytime in algebra, it doesn't have to just be with rational equations. Anytime in algebra that your variables go away, cancel out, they're gone, okay? And then you get a, yes, baby. Okay, I'm so happy about it. Okay. Okay. I'm sorry. Whenever your variables cancel and you get a true statement, that means all real numbers are your solutions, or you have infinitely many solutions. Okay? That means you could plug 1 in and it would work, and 2 in and it would work, 3, 4, 5, 6. The only thing you can't plug in, all real numbers except, of course, 0. Because we can't put a 0 in the denominator. In this particular case. So that's what the true statement means. And if you get a false statement, that means there's no solution. So because this side, I made it to be equivalent to that side, I made it equivalent to this side regardless of what x is, which is why we ended up with a all the numbers in the world type of solution except 0. Okay, select all the possible equivalent equations to that. Okay. So this one has the x plus 5 and this on the bottom. On the right side, that and that. And then they've multiplied the top and the bottom by the same thing. So this one's okay. Over here, the right side's the same. The left side appears to be factored. It better be factored correctly. Do 4 and -3 add? Right? Like, do you remember the factoring? It needs to add to 1 and multiply to -12. And they do. Okay? So this thing factored is this. So this one's good. This one. Let's see. This doesn't look good. It's not looking good. What did they do here? Oh no, maybe they multiplied that over? Am I crazy? Did they just think they can take their denominators and put them in the numerators? Is that what they did there? If so, get out of here. Can't do that. Okay, over here, let's see what they're doing. We have this guy and then that guy factored. And then they multiplied the top by something and the bottom by something else. So right off the bat, I'm thinking this is fishy. And then over here, again, opposite stuff. Like, okay, this is wrong on 2 levels, okay? This is not the same thing top and bottom, okay? But at least if it was the same as this, it would have been okay because then they would have multiplied the same thing on both sides of the equation. But they didn't even do that. So they didn't multiply top and bottom by the same thing. They didn't multiply both sides of the equation by the same thing. This one's not good. Not good at all. Okay. And now this one appears to be okay. In this one, it looks like they just cross-multiplied. So they got that times the 7, and then the x plus 5 times the x minus 3. That one's okay. Alrighty. Let's see what advice we'd give a classmate to help them understand what an extraneous solution is. So this student did this problem. Looks like they cross-multiplied. So this times this, and this times this. They multiplied through, they moved everything to one side. Then they factored what they got. And then they got, wait, I don't understand. Oh, I understand. I don't know why. I thought I was either finding something wrong here. But this is a perfectly fine example where they solved it and they didn't get both the solutions. They didn't say x equals 5 and x equals -7. And then -7 is an extraneous solution. So x is only 5. Okay, let's explain what an extraneous solution is. An extraneous solution looks like a solution, works in all these steps where we have no denominators, works when no denominator, but puts a 0 in denominator of original problem. Right here. That's the problem. That's an extraneous solution. Okay? Alrighty, let's keep going. B. Okay. Oh my god, thank goodness. We're finally solving. Alright, let's do it. Let's see. Let's see what we need to do. I wanna find my method that I taught in my classes was find the common denominator. Then forget the common denominator. That's our method. So first thing I'm going to do is find this common denominator, meaning I'm going to factor this. All right, remember this is like two things in a bag, and we don't know what those two things are until we see what multiplies to make 6 and adds to make 5. So that's 2 and 3. Whenever everybody's positive, everybody's positive. So 2 plus 3 is 5, 2 times 3 is 6. That makes this equal to 2, oh, I'm sorry, no. Equal to x plus 2 and x plus 3. So that's what this is. So we really just have 3 over this. And then on this side I have x plus 3. So my common denominator is x plus 2, x plus 3. That would include everything that's in the denominators. This one already has an x plus 3. So all it needs is the x plus 2. Sorry, instead of find common denominator for our method, I should have said get the common denominator. Because here we found what the common denominator is, but here we're getting a common denominator between all our fractions. That's the important part. Okay, now all my fractions have a common denominator. This one is 3 over x plus 2, x plus 3. This one is x times x plus 2 over x plus 2 times x plus 3. So we've got a common denominator, which means now I can forget about my common denominator. Pretend it is gone, okay? And just focus on the numerators. We need 3 to equal x times x plus 2. What must happen here is distribution. So 3 must equal x squared plus 2x. And now, whenever I've got an x squared and an x, I move everybody to the same side to get 0 equals x squared plus 2x minus 3. And now this is something I got to try to factor. So what multiplies to negative 3 and adds to 2? Well, it can only happen with 3 and 1. The 3 is going to have to be positive because the 2 is positive. And now positive 3 times a negative 1 makes a negative 3, which makes this right here equal to x plus 3, x minus 1 equal to 0. Which then means that x equals negative 3 and x equals 1. But we are always skeptical. Don't trust them until they prove themselves. Does negative 3 put a 0 in what my original denominator was? And holy moly, it does right here. And right here. Big problem. Huge mistake. Big mistake. Huge. Bad. This one is bad. This one's an extraneous solution. But the one, that one's not hurting anybody. There's our answer. All right? Our answer is just x equals 1. Let's go over here. This one's cool, I guess. It's fine. We got to factor this to see what's in the bag. But you guys, this factoring is just pulling out the common x. All right? So here there's an x, here there's an x. We can take this x out and have this be 1x less than it is now, plus, and this have this x on the outside, so now it's just x plus 4. So you take the x away from these two, you put it in the front, and you see what's left right there. So now I can see that my common denominator is x plus 4 and that x. And so now I need to get the denominator, then forget the denominator. So this one already has this common denominator. This one just needs that x. Top and bottom. And now that they both have that common denominator, I will forget it. All right? So I have 15 equals, and over here I gotta distribute x squared plus 2x. And now here we are, you guys, back to what number 7 was like, okay? If this keeps happening, I'm not going to keep solving it. I'm going to hope that you guys learned how to do it and you can do it yourselves. Again, I see x squared and x, so I move the 15 over to get 0 equals x squared plus 2x minus 15. Then I put the negative 15 on the top and the 2 on the bottom. And what can multiply to 15 and still may add to 2? 3 and 5. The 5 is going to have to be positive because the 2 is positive. But to multiply to negative 15, the 3 is going to have to be negative. Which means this thing right here factors into x minus 3 and x plus 5. Just these two numbers equals 0. That makes it so that x can be 3 and x can be negative 5. All right, the opposite of those. Boom. Don't trust them. Looking back, my original denominators are okay with a 3 and a negative 5. So we actually have two solutions, both of those. Number 9. I can see the denominator. That's nice. So my common denominator here.
Mama!
Yes, Mama.
I found a treasure piece.
Oh, good. Good job. You did? Where?
In the cave.
Oh, good job. Okay. The common denominator here is x times x minus 1. And then this one already has it, and this one needs the x, top and bottom. Okay, now both my fractions have a common denominator, so I forget the denominator, and I distribute the numerators. I have 2x squared minus 3x equals 2. And so in this one, I got to subtract the 2, right? Because there's an x squared and there's an x. So just like these two problems. And I get 2x squared minus 3x minus 2 equals 0. Now this is one of the 5% of the times that we don't get a straightforward factoring problem, okay? So for this one, here's how we factor. We multiply this 2 by this negative 2 and get negative 4. And then we see what multiplies to negative 4 and adds to negative 3. So that's going to be negative 4 and positive 1. So it's 4 and 1. The bigger number matches the bottom number. So the 4 is negative, and then to multiply to be negative, that one's positive. But you guys, this is where we cannot go to our parentheses. Because of the existence of this number in front of the x squared, once we find these numbers, we just have to go to the box. It doesn't make it terribly harder. It just makes it one extra step. And so what we do is we put 2x squared in the first box, and we put negative 2 in the last box, and then we put minus 4x and plus 1x in the other two. Because these two together make the negative 3x. And then now we factor. What was in both 2x squared and x? Just x. What's in both negative 4 and negative 2? Negative 2. What do both 2x squared and negative 4x have in common? 2x. And what about 1x and negative 2? Just 1. That makes this thing factor to those. That means that this right here is 2x plus 1 times x minus 2 equals 0. Which means that either x equals 2, that's what I get from here, or in this one, do you remember my trick? Listen, if you're good at solving an equation, you don't need my trick. 2x plus 1 equals 0, solve it. Subtract the 1, divide the 2. Great practice. But you can also See how we took the opposite of this number here? Take the opposite of this number here too. Just divide it by that number also. All right? These are the answers. And we're going to be skeptical for a moment. Our denominator couldn't be 0 or 1, but that's neither of these. So these are both solutions. Man, this is quite the homework assignment. Okay, let's keep going. Okay, this one's dumb. I'm not gonna do it. Look, you guys, look what they're trying to do. They have a 6, an 18, and a 2. This fraction is like it's like writing 5 over 10 instead of 1 over 2. All right? The first thing I want to do is simplify this madness. You don't need to. If you didn't catch this and you were going to go give everybody a common denominator of 2x cubed, there's nothing wrong with that. Just multiply this by 2x squared on the top and the bottom and have at it. You can do that. It'll work, okay? But I'm saying, why don't we divide everybody by 2 so that this becomes 3x squared and this becomes 9x and this 2 becomes a 1 and goes away essentially. And then let's also notice that I have an x squared here, an x here, and an x cubed here. They all have an x. So let's cancel away an x here and take one of these x's away and take one of these x's away. Okay? And now we can rewrite this as 3x plus 9 divided by x squared equals 5 over x. All right? No harm, no foul here. All right? Okay. So now my common denominator is just simpler than it was. Now the common denominator is x squared. So let me go over this with you for a second. This guy has an x. This guy has 2 x's. And remember, everybody wants to bring what they want on the road trip. This fraction wants to bring 2 x's on the road trip. 1 x will not be enough for it. So in order to keep this one happy, we got to bring 2. This one's happy because there's at least 1. Okay? So the common denominator is x squared, and that means that this fraction just needs an x on the bottom and an x on the top to have the common denominator. And so now this denominator is x squared and this denominator is x squared, so I have a common denominator. I'm going to forget the common denominator and focus on my numerators, which is just 3x plus 9 equals 5x. And I hope you can see, if you earlier were going, but that was so much work. It's just so easy to multiply by 2x squared on top and bottom. Look at now what a simple equation we're solving, and that's because we took the time to simplify, okay? You would still get the same answer as long as you didn't make a mistake. If you didn't simplify, you would just have some x squareds on your hand and some things to simplify now. So sooner or later, you were going to have to simplify it. Let's divide both sides by 2x. 9 equals 3x. Divide the 3. And x equals 3. And 3 is not a problem with my original denominator. So there's our answer. All right, let's look at this fun problem. Fill in the blank to write a rational equation that has the extraneous solution x equals 2. Oh, fun. Okay, let's see. We have a common denominator, so let's forget the denominator, all right? Now I have this numerator, this unknown numerator, and I want it to equal 3x plus 7. And then at the end, whatever this is, I want my answer to come out to x equals 2. So if x is 2, 3 times 2 is 6, and 6 plus 7 is 13. So I kind of just need this side of the equation to be 13. Then you would subtract the 7 from both sides and get 6 equals 3x, right? Then divide both sides by 3, and you get x equals 2. 13 is the simplest thing that you could write here, but it's not the only thing. Okay, you could get fancy if you really wanted to. This is a mx plus b linear type of thing. Why can't that be a mx plus b? You could make that like 2x, right? So then this 2x would subtract from this and become x. But then you would need whatever is here when the 7 is subtracted from it to make that. So you could make 2x plus 20, right? Because look, now minus 2x, minus 2x. You get 20 equals x plus 7. You could go minus 7, x equals 13. Oh, shoot, no. I lost track of the number I was trying to get. I made 13 when really I was trying to make 2. So my bad. If it was a 2x, I subtracted the 2x. Now I want something here that when 7 is subtracted from it, I get 2. So I'm so sorry. Instead of the 20, I would rather have a 9. Okay. So yeah, minus 7, 9 minus 7 is 2. So you could see this could be 13. Or you could have chosen 2x plus 9. Or you could have put 3x or 4x or 8x or 19x and then chosen that number to make this happen, okay? So the possibilities are endless. Do whatever you want, all right? Okay. Determine each sum or difference. I think this is having us maybe practice some common denominatoring. I'm not going to do it. Let's move on. I recommend you do it, but I'm not going to do it. Okay, here we are. We're going to rewrite the expression as a single fraction. Okay, the same way that 1 over 8 plus 7 over 8 is you add the 1 and the 7 and you get 8 over 8, right? So the denominator remains the same and the numerators get added together. I just added x squared plus x plus 5. That's it. Same here. They have a common denominator. The answer will have that same denominator. And then you're going to take 4x plus 1 minus 2. So what's plus 1 minus 2? It's minus 1. Alrighty. Next, fill in the blanks to write an equivalent expression to that whole thing. Okay. Okay, it looks like what they're doing, if I'm not mistaken, is getting a common denominator. So if I'm not mistaken, what they did was go to each of these fractions and have them become a 5x on the bottom. So this one needed a 5 on the top and a 5 on the bottom. So 5 over 5x. And this one is already 1 over 5x. And then this one needed, because it was over 1, it needed both the 5 and the x. So it became 35, 7 times 5, 35x over 5x. Okay? So you guys, this is like the same as if they said rewrite this with a common denominator of 5x. That's what that is. Okay. Which of the following equations is equivalent to that? All right, let's get serious here. Okay. Yeah, I'm thinking no. what did they do? They multiplied the 2 by x, and then this fraction by x minus 6 just on the numerators. And I don't see, if they did something weird, like throw an x in right there and throw an x minus 6 in right there, that's fine. But I would have needed to see the same thing happening to the denominators or the same thing happening to this side of the equation. And I'm not seeing either of those happen. So that's a no. Let's look here. In this one, they multiplied an x in the numerator, but they also multiplied 1 in the denominator. So far, it looks okay. Over here, they multiplied an x minus 6 in this numerator, but they also multiplied it in the denominator. Fantastic. They're doing okay this time. And then in this one, it looks like they multiplied an x times x minus 6 in the numerator and also in the denominator. They did it. They did it. They figured it out, you guys. Okay. This one is bad because they forgot the denominators, but you can't forget denominators. You can forget common denominators, but not uncommon, not mismatching denominators. And then in this big hot mess, this is their problem. So they matched these up. That was good. They matched these up. That was good. But then on the 3 side, they only multiplied the numerator and not the denominator. That's okay, baby. Now just pick it up, okay? So that's the problem there. Okay. Luca, you just threw all of Mama's stuff on the ground, right? Are you going to pick it up now? Thank you. Okay. Select all the possible first steps to solve the equation, yada, yada, yada. Okay. Let's see. A possible first step here, is it to multiply this first fraction by x over x? Sure, because let's be a little bit clear about what we're doing. This 2 is over 1, and the common denominator here is x times x minus 2. So this one needs an x. That's good. And then over here, multiplying this is good. I guess this would be a possible first step. It's not a complete first step because we would also need some stuff happening to the 2. But maybe they were going to get the left side to have a common denominator first, then get the right side to get a common denominator. I don't know. But to me, this one's okay because they didn't do anything that they didn't balance. Everything they did, they balanced. This equation is okay to me. This one, boom, boom, and boom. Fantastic. This is a more complete first step. This one. Okay, so here what they did is okay. They did that, balanced it. Did this, balanced it. Then did that and balanced it. What I don't understand is how does this help us solve? Because now we have this different denominator here, a different denominator here, and a different... We have 3 different denominators. This is not getting us any closer to solving. It's not getting us any closer to getting this denominator. And over here, these 2, I would say no way. And the reason I'd say no way is because they're ignoring the fact that this 2 has a denominator of 1 that needs to also be changed. You cannot just go multiply something without also doing it to the denominator. So if you ask me, I would say A and C, but not the other ones. Okay. Now we're going to rewrite these equations without denominators. Okay. So we're going to get the common denominator. Then we're going to forget it. Okay? The common denominator here is x times x plus 3. So we're going to go to each one. On this first one, I'm going to multiply the top by x plus 3 and the bottom by x plus 3. On the second one, I'm going to multiply the top by x and the bottom by x. And on this third one, I'm going to multiply it by x and x plus 3. X and x plus 3. Okay, that looks so messy that I am going to rewrite it this time. what I have now is x plus 3 over x times x plus 3. I have 2x over x times x plus 3. And I have 4x times x plus 3 over x times x plus 3. So what I've got now is a common denominator everywhere, so it's time to forget the common denominator. But what also I have, you guys, is a situation where I need to distribute, and I'm going to draw these lines right now so I don't forget. This is x plus 3 plus 2x equals 4x squared plus 12x. And now I combine some like terms. So x and 2x is 3x plus 3 equals 4x squared plus 12. And then I want everything on one side because I have an x squared and an x. So the best way to do this is going to be factoring a quadratic formula. Either way, I need it to equal 0. So now this cancels and this cancels, and I have 0 equals 4x squared minus 3x plus 9. Okay, I just kind of put this in the order that I knew I would want. And now I got to factor it. And this is unfortunately the kind of factoring that involves this and this. Okay, so we're going to have what? 4 times 9 is 36. What multiplies to 36 and adds to negative 3? And it's going to be... what's it going to be? Oh, does it not factor? Wait a minute, we're not solving. We are not solving. We're just rewriting it without denominators. So technically, I was done here. Or here. Or here. But I don't have to solve. Okay, thank goodness. Because it didn't look like it was going to be nice. Okay, here we go. This 1 is over 1. My common denominator here is 2 and x plus 1. So let's go multiply everybody by what they need. This needs an x plus 1 and an x plus 1. This needs a 2x and a 2x. And this one needs it all. 2x, x plus 1. 2x, x plus 1. And now I would rewrite this as 5 times x plus 1 minus x times 2x, which is 2x squared. Let me write the bottoms. It's too messy. Okay. Now they have a common denominator, so I can forget the common denominator. And remember, by the way, you guys, I taught you guys this in class. I don't like really gimmicks. This one works. I told you guys it's logical because if you want two things to equal each other, if you want this side to equal this side and the bottoms already match, you just need to make the tops match. I also told you that mathematically what you're doing is multiplying everybody by the common denominator of 2x times x plus 1. So it would distribute through and cancel each of those out. Okay, so don't think that the get the common denominator, forget the common denominator thing is like a gimmicky trick. It's real, okay, backed by mathematics. All right, now that they're gone, this becomes 5 times x plus 1. I would distribute if it wanted me to solve, but it only said to rewrite it without a denominator. So personally, I'm not going to do extra work that might result in an error and then cost me points. They told me write it without a denominator. Here it is without a denominator. Okay, now they want me to solve. So sure, I'll do it. Okay, common denominator between 3 and 6 and the x's situation, it's going to be a 6x, okay? So I gotta multiply this first fraction just by 2 top and bottom. This fraction needs a 6 top and bottom. And this fraction needs an x on top and bottom. And so it becomes 2 times 2 is 4 over 6x plus 6 over 6x equals x over 6x. And then I have a common denominator. So I forget the common denominator. And I end up with 4 plus 6, which is 10, equals x. And that doesn't put a 0 on my denominator, so that's it. And now over here, I have a common denominator of x times x minus 1. So let's go. I need to multiply this guy by x minus 1 on the top and bottom. I need to multiply this by x and x. And I need to multiply this by x minus 1 and x minus 1. So this, now everybody has a common denominator, but my numerators are x plus 3 times x minus 1 here, plus 4x here, and then minus 1x times x minus 1. So minus x times x minus 1 here. And there's some distributing to do, okay? There's this. Don't forget to distribute the negative as well. And over here, you can use the box if you want, or all of that if you want, whatever you want. I do really like the box, you guys. Here, I'll do it with the box right here. Look how nice it is. X plus 3 and x minus 1. X times x is x squared, negative x, 3x, negative 3. So I can just come over here and rewrite this as x squared, 3x minus x is 2x, minus 3. And then plus 4x. And then equals a negative x squared. And then plus x. Okay? Now, don't get excited. All right? This x squared is not going to cancel with that x squared. Okay? So what I'm going to do is combine these like terms. Be careful, you guys. When we get excited, when we see x squared, negative x squared, and we want to cancel it, we make a mistake. All right? You must add this x squared because it's traveling across the equal sign. Okay? And that means I also have to subtract the x over to the same side. This is 2x squared plus 5x minus 3 equals 0. And, God, that's so annoying. How many of these are they going to give us? Okay, I'm out of space. Let's come over here to solve 2x squared plus 5x minus 3 equals 0. Boop, boop. What multiplies to negative 6 and adds to 5? How about... why am I being weird? Negative 1, positive 6? Negative 1 and positive 6. And then now, box, because there's a 2 here. So 2x squared minus 3 minus 1x plus 6x. I can take out of here a 2x and out of here a negative 1. And out of these guys, I could take out just an x. And out of these guys, I could take out a plus 3. So this is 2x minus 1 and x plus 3 equals 0. That means x equals negative 3 and x equals 1/2. Remember, opposite of that number, opposite of this number, divided by that number. And now, gotta make sure I don't have any zeros in the denominator with these two values. And I don't. So, okay, looks like we get to move on to this one. All right. Let's see what we have. I want to factor this by taking a 2x out of it. When I take a 2x out, I'm left with an x plus 3. That makes my common denominator 2x times x plus 3. So that means that this fraction needs the x plus 3 on top and bottom. This fraction needs a 2x on top and bottom. And then this fraction is done. It already has it all. So I can forget the common denominator now and deal with this x plus 6, x plus 3 from this numerator, minus 6 times 2x, which is 12x, and it'll equal 16. And you guys, I'm going to bring it up. It didn't happen, but this minus was dangerous. Because if I hadn't multiplied something that didn't require distribution, I would have to remember to distribute the negative. So for example, if I had multiplied this 6 by x plus 1, I'd be distributing not just a 6, but a negative 6 into it. All right, so just keep that in mind with the negatives. If distribution is required, subtraction is a negative that must be distributed. Okay, let's go to the box to multiply out x plus 6 and x plus 3. And that is x squared plus 9x plus 18 minus 12x equals 16. And then 9x minus 12x is negative 3x, x squared. And can we subtract the 16 since we know we're going to have to anyway? So you guys, you don't have to do it my way, but you do have to multiply these out however way you want, and you do have to combine like terms, and you do have to move everybody to one side and set it equal to 0. And if you do it your way and get the same as this at this point, then we're all good. And now we factor this. What multiplies to 2 and adds to negative 3 can only be negative 2 and 1. So x minus 2, x minus 1 equals 0. So x equals 2 and x equals 1. They're both okay. They don't make anything in any denominator I ever had 0. Okay, let's look at this. Solve this equation for x. Okay. So what they're doing is they're telling you that x cubed minus 1 factors into this, okay? So we're not going to be afraid of this. We're just going to realize that all these x cubed minus 1s are this. So imagine all of this here and all of this here. That would actually make this my common denominator, right? Because it has what this guy wants, and it is these guys. And all I have to do, you guys, is just come to this one and multiply it by x minus 1 in the numerator and the denominator. So far, this is looking easier than the other questions. Now, there's a common denominator here. They all have this x minus 1, x squared plus x plus 1, because remember, this is that. This is that. And this we multiplied by what it was missing, which was the x minus 1. So now forget your denominators. We just have 2x plus 2x squared minus 2x, because don't forget to distribute, equals 32. Oh, look how nice. The 2x's cancel. So I don't have to factor for once. I just have 2x squared equals 32. Divide both sides by that 2. X squared equals 16. Oh my gosh, it's even a nice one. Square root both sides. X equals, don't you dare forget that plus or minus 4. And neither of these is a problem in any of those. Easiest problem in this whole homework, you guys. Get out of here with that. Okay. Over here, solve these either algebraically or graphically. Well, I'm going to tell you that graphically, when given a graph like this, is definitely the way to go. Where they intersect is the solution. So x equals 2 and x equals -3. Boom, boom, done. Okay? You can also do it algebraically by setting this equal to this, and then moving everybody to one side, factoring, solving to get this. And over here, look at this. We've got ourselves, it looks like something going on right there, and it looks like something going on right there. So it looks like x equals 1 and x equals -2. I'm not so confident about it with this graph. So I might do it algebraically, which is to set this equal to this and solve. I encourage you to do it. I'm not going to because this video is already 50 minutes long. Okay, good luck, you guys. I've done this. I've done this kind of factoring and solving problem a lot, so you can do this. Believe in yourself.